In this practice, light of wavelength 400 nanometers illuminates a pair of slits separated by the 0.1 millimeters. A screen is placed 2 meters from the slit. Calculate the distance of the first bright fringe from the center of the central maxima. So we'd like to write down the figures. Y-axis is a slit is placed is here. This distance is d is a 0.1 millimeters, and the screen is placed here. This is screen. Distance between the screen to the slit is a capital R. Is a 2 meters from the slit. Then maybe we can choose the axis. This is x coordinate. And the y-axis here. And then we could consider the path between the two paths. The path to this point on the screen is r sub 1. And this is r sub 2. Then when the r sub 1 minus r sub 2 is absolute value is the integer multiple of the lambdas. This is the condition for the bright band. And then actually you can use equations. If this is r y, so r sub 1 minus r sub 2, this is express square root r square plus y plus d over 2 squares minus square root r squares plus y minus d over 2 squares equal m lambda. You can write down these equations. Right? Then if you divide it r, it becomes y plus d over 2 over r square minus square root 1 plus y minus d over 2 over capital R square equal m lambda over capital R. If you pick up just only the first part, usually R is much larger than Y. So this expressions y plus d over 2 over r squares is approximate 1 plus 1 over 2 y plus d over 2 over capital R squares. Also, this is 1 plus y minus d over 2 r squares is 1 plus 1 over 2 y minus d over 2 over capital R squares. If you substitute these equations, in approximation of the capital R is much larger than y, then these equations it becomes 1 plus 1 over 2 y plus d over 2 over capital R squares minus 1 plus 1 over 2 y minus d over 2 over capital R square equal m lambda over capital R. I have this equation. Then 1 is going to be cancelled out. And then most of the part is cancelled out except the cross terms put here. So it's going to be 1 over 2 R squares plus Y times D. And the Y square terms and the D over 2 square terms is going to be cancelled out in the both sides. But this times is this negative sign becomes positive. So it's multiplied twice. It's M lambda over capital R. And the 2 is cancelled. One of the R is cancelled. Then you can find that the position of the bright band is expressed M R lambda over D. So this is the positions of bright bands. On the screen. Then once we have these equations, we could answer today's questions. Today's question is first fringe. So M equal 1, you need to substitute. Y sub 1 equal R lambda over D. R is 2 meters. So D equals 0.1 millimeters and the lambda equal 400 nanometers. So you can just substitute 2 times 400 times 10 to minus 9 meters squares over 1 times 10 to minus 4 meters. Then it's going to be meter, one of the meter is cancelled out. So this is 8 times 10 to minus 7 plus 4 is minus 3 meters. So answer is 8 millimeters. This is the answer to this practice.